And the lighting is back. And by that, I mean, hopefully it won't just glitch out every so often. Also, the two hot spots are at the back from the floodlights. That's what happens. I also wrote spring snow on this side. I was definitely trying to see how long these lasted, to be honest. Maybe not use these. So the construction of these is typically an aluminium extrusion and then the end caps. And if you wiggle the end caps, they usually slide off, revealing the potting compound. Is the same going to happen at the other end? A little bit of pressure is sometimes needed. Sometimes they come out easily, sometimes they don't. Let me stick a screwdriver under that and use more pressure. Oh, that one as well then. That's annoying, but that's okay. It will come out. Now what I'm going to do here, once I've got this out, is I'm going to try and hopefully just chop those wires off. Snippy, snippy. Hopefully I can grab the pliers here and just flex this out a little bit and maybe encourage it to let go of what's inside. And it'd be nice to slide it all out in one because you can reuse these little housings with the end caps for potting electronics, which is quite useful. Not when you do it far too much like I've just done though. Maybe that is going to help though. I'll just do it like that. Screw it. Is that going to make it come out? Am I going to cut myself horribly now? No, I've really messed this up. That's by using overzealous force, so that's fine. That's the way I shall go with this then. The chances of me actually needing to pot something are fairly slim. Well, obviously they were until I said that. So let's get this open. Oh, that's sticking. It's sticking hard. So that would not have slid out easily. So this was the correct way to go. Violence. Still not coming out that easily though. What if I stick a screwdriver up the side here? Or indeed just grab that and prise it off. Oh, it is bonded on well. It really has bonded on well. Here we are. Right, well that's not potting anything anytime soon. In the recycling container it goes. Right, what do we have here? We have the plastic film, which I'd normally expect to see over the circuit board, but could also be over the components. Let us try digging in here. And it's one of these things that if this starts taking too long, I shall pause. Because sometimes the potting compound is super soft, and this is fairly soft. It's a silicone type of material, and sometimes it's not soft. Or it gets really wrapped around the components. We're looking for this capacitor anyway. That's one of the things we want to see. That's the output capacitor, which is a prime suspect here, since they are often stressed quite significantly. I wouldn't necessarily expect to see it domed though. They don't always dome when they fail. And it could also be other components. It could be what they call the bootstrap capacitor just starting to drop a bit and cause intermittent retriggering. It could even have been a bad connection, because sometimes heat cycling can cause connections to fail. This capacitor here is probably the 240 volt input capacitor, which is going to charge up. And there's a little bootstrap capacitor there. Nothing really obvious. This is the one that would hold a charge, but having said that, because it was working when it failed, it probably doesn't have a charge. But tell you what, let's just bridge those connections anyway, shall we? Nothing, if I got a good connection. Here's the plastic film that is normally covering the circuit board, but it really has kind of crept right in everywhere, this compound, which is what you want. It's supposed to make it watertight for outdoor lights. Better in a way than the one that I've just basically swapped in from a waterproofing perspective. I could zoom down this just a little bit. Get closer. I could have done that right at the beginning, couldn't I? Yes, but I'm not very organised. Get other bits off. See if we can find the diode. Is it a surface mount diode? Is it a through-hole diode on the secondary side? I'm reckoning that might be the diode here. Maybe even more than one diode. Here is, oh, they've glued this stuff to the bottom of the circuit board, and it's also, well, they've put a dot of that material in before kind of sticking it. Just randomly playing myself now, haven't I, really? I don't think this is going to find anything decisive, should I say, because the thing hadn't failed completely. It was just starting to show the earliest signs of glitching every so often. That glitching looked like the bootstrap circuit restarting. Basically, when you turn one of these lights on, there's a slight delay before it lights as it charges a capacitor, and that capacitor then powers the power supply just long enough for the power supply to actually start powering itself. What's the separation going to be like? Don't really know what the separation is going to be like in the transformer. Let's try the spudger as a way to carefully slice this stuff off. Sometimes it's better to pick it off though, because if you slice it, sometimes that just leaves a thin layer on that can hide details and become hard to get off. Hopefully there is electrical separation. From the input to the output, it would be nice if there was. At the moment I'm not seeing a clear path of electrical separation. Oh, there it is. Oh, with a wee slot through the circuit board as well, so they've made some kind of effort in electrical separation. And I'm guessing that these down here are the diodes. There are two diodes. Are they both associated? There's a class Y, I would guess, very, very small class Y interference suppression component. But then there's that strange component that's in the primary side. That may be possibly part of the bootstrap circuitry, who knows? Or it might be part of the filtering circuitry to protect the switching transistor in here. He said point at the transformer, not the switching transistor. Right, tell you what, rather than bore you by taking too long to do this, I shall pause momentarily and I'll see how much of this stuff I can get off. One moment, please. Depotting is complete. What a mess that has made. It has been reverse engineered, all fairly logical, some suspect capacitor readings. Let's take a look at the circuitry. So I'll zoom in a little bit. Sorry, there is some potting compound left. It's just pretty hard to remove it all. The incoming supply goes to a component which just has one red band. I don't know if there were others at some point, but one red band might be it. It looks as though it is a 2 ohm fusible resistor, perhaps, a dedicated resistor for that. Then we've got a bridge rectifier formed from 4 discrete diodes, and just off shot here is a capacitor folded over the top of those. We have a PL3537 chip. I could only find a very vague schematic for that. However, there is a partner chip to it, the PL3535, with a lot more data, and it's got the same schematic, so it's from the same family. There is a little wire link here. I don't know what that's for. It's very hard to read what that says. MPT something? Is it perhaps a thermal fuse link or just a fusible link? I don't think it would just be a fusible link, because if something failed on this side, it would potentially blow the diodes, and this is after the diodes between them and the main reservoir capacitor. On the control chip side, it has 2 windings in the transformer. It's got the primary winding and the feedback winding, and it's got the secondary winding. That little capacitor there, I thought that was a class Y. Well, it is a class Y type capacitor. For interference suppression, it's not. They've just used it because it's a handy value that is commonly used as a class Y suppression capacitor. And it's used in conjunction with this diode and a couple of resistors on the other side. It's the snubber network across the primary. I'll just mark that one as feedback, and that is secondary, not necessarily their actual pin positions. The feedback, although it's fairly well placed for this, is going through a diode, but it's also going through a resistor divider. I'll show you that on the other side. And that charges this capacitor here, which powers the chip, but it does also have another means to charge it. It's a bootstrap capacitor. It is suspect. There is also a little tiny, I think it's 22 nanofarad capacitor for the chip for internal references. On the output, we've got a diode going to the capacitor, and then there's a slight a resistor to provide a basic slow discharge, just in case the LEDs go open circuit, just so it can actually still remain active, but not actually pumping current through the LEDs. On the other side, we have a chain of resistors here, 750k, 3 in series, trickle charging the bootstrap capacitor, which is down here. That can also get charged by that diode. There is a set of resistors as a divider from the feedback winding to actually, and actually I think that is right. That is correct. Yeah, because that's the positive and that's the switching through the, okay, chip. But these provide a divided voltage to an input pin in the chip just to actually indicate when things are going horribly wrong. There is a current sensing array of resistors, two 1.5 ohm resistors in parallel for limiting the amount of energy put into the coil on each cycle. And there are the two resistors for discharging the snubber network, 200k, and then there is that slight load, 22k. It's a fairly high value compared to normal just because it's quite a high voltage output, about 36 volts. What else is there? Not really much. Let's take a look at their schematic, which I've filled the values in on. So, if I bring this in here, is that way too bright? It's not too bright, it's fine. So, the mains comes in here, AC in. There's that mysterious red banded, just 2 component that looks like a fusible resistor and measures just over 2 ohms, which is coincidental, or probably not coincidental. There's a discrete bridge rectifier, and there's that mysterious link, which might be a fuse, maybe a thermal fuse, designed to actually trip out if the whole thing overheats, but they've not put that in. There's the main smoothing capacitor, 22 megafarad, 400 volt. It measured 22 megafarad with a series resistance of 0.98 ohms. Oh, I should zoom out a little bit for that, because I've got some numbers off shot here. That's okay though, because this capacitor is a low frequency capacitor. It doesn't have to be low ESR. So that 0.98 ohms is absolutely fine. It's not a suspect in this case, and it's measuring fairly sensibly for that. All it has to deal with is 100 to 120 hertz. There's a chain of resistors that charge up that little capacitor, 4.7 megafarad, 50 volt. It measured 4.5 microfarad at 1.7 ohm, which seems almost a wee bit highish for a low ESR capacitor, which I think that should be. But they may not have used a low ESR capacitor just to save money. And to be honest, I feel that should be a low ESR capacitor. There's the little 22 nanofarad capacitor used for internal voltage references. There is two 1.5 ohm resistors used for current sense, and the current flows through the primary winding, through the switching device in here, and then through those resistors, and when it detects it rises up to a level that it reaches a voltage threshold, it will then turn the MOSFET in here off. I think it's a 600 volt MOSFET it's got in there. When it turns off, there's the snubber network. A little diode diverts from the primary. The collapsing field, it just catches the tiniest little start before the secondary circuitry can kick in, and just shunts it into this tiny capacitor, the 2.2 nano blue class Y capacitor, and it's got the two 200k resistors for a total of 100k across it, just to keep that discharged so it's ready to take the next spike. It's covered across to the 220 megafarad 50 volt capacitor. That was measuring 214 microfarad, 0.11 ohms. It's not a bad resistance for a low ESR cap, I don't think. Not sure. But I did measure a smaller capacitor, low ESR, with an equivalent rating, and it came out roughly the same. But having said, the other one was much smaller, so that may actually be quite a high resistance for that. Certainly the Panasonic equivalent said it should be something like 0.03 or something like that. So it's possible. I think that this capacitor here is the primary suspect for what's been going wrong here. Then there's that 22k discharge resistor, and then the actual LED itself. And the 22k resistor is if the voltage, if the LEDs go open circuit, it still poses a slight load, because that just keeps things from climbing too high here. It keeps things a bit stable, caps the voltage a little bit, I guess. Not totally needed, because if that was, not sure. They always put them in. I've never quite worked out what that is there for. I think it is to provide that slight load to stop the voltage creeping high on that capacitor when it's open circuit. But I don't know if it poses also a slight load in the secondary to keep the primary running, because there already is a slight load from the feedback circuit, although it's not going to be huge because it is just feedback. But that is it. I'll guess capacitor degradation was the main issue here, why the light failed. If it was a one-off power supply that you couldn't get replacements for, what I'd do is I would carefully depot it as I have, fairly carefully, one of these leads is given off in the track here, but that's all right. It could be so direct onto the lead. To repair it, I'd change that capacitor and the bootstrap capacitor, and while I was at it, I might just change the power supply capacitor, because that should theoretically give it a new lease of life. But there we go, the light is fixed anyway. We'll see if it dips at any other time. If it does, that would be extremely disappointing. But in the meantime, that is it. It is fixed, and we're ready to begin making videos again without those flashy interruptions.